हेलो एवरीवन, वेलकम बैक टू माय चैनल। तो आज के वीडियो में हम देखने वाले हैं एनसीईआरटी इकोनॉमिक्स क्लास 12, जिसमें आज हम देखेंगे चैप्टर 4 जो कि है द थ्योरी ऑफ फार्म अंडर परफेक्ट कंपटीशन। तो शुरू करते हैं हमारा आज का चैप्टर। इन द प्रीवियस चैप्टर वी स्टडीड concepts related to a farm's production, function and cost curves. The focus of this chapter is different. Here we ask, how does a farm decide how much to produce? Our answer to this question is by no means simple or uncontroversial. We base our answer on a critical, if somewhat unreasonable, assumption about farm behavior. A farm, we maintain, is a ruthless profit maximizer. So the amount that a farm produces and sells in the market is that which maximizes its profit. Here we also assume that the farm sells whatever it produces, so that output and quantity sold are often used interchangeably. The structure of this chapter is as follows. We first set up and examine in detail the profit maximization problem of a farm. Then we derive a farm supply curve. The supply curve shows the levels of output that a farm chooses to produce at different market prices. Finally, we study how to aggregate the supply curves of individual farms and obtain the market supply curve. Perfect competition. Defining features. In order to analyze a farm's profit maximization problem, we must first specify the market environment in which the farm functions. In this chapter, we study a market environment called perfect competition. A perfectly competitive market has the following defining features. The market consists of a large number of buyers and sellers. Each farm produces and sells a homogeneous product. That means the product of one farm cannot be differentiated from the product of any other farm. Entry into the market as well as exit from the market are free for farms. Information is perfect. The existence of a large number of buyers and sellers means that each individual buyer and seller is very small compared to the size of the market. This means that no individual buyer or seller can influence the market by their size. Homogeneous products further mean that the product of each farm is identical, so a buyer can choose to buy from any farm in the market and she gets the same product. Free entry and exit mean that it is easy for the farms to enter the market as well as to leave it. This condition is essential for the large number of farms to exist. If entry was difficult or restricted, then the number of farms in the market could be small. Perfect information implies that all buyers and all sellers are completely informed about the price, quality, and other relevant details about the product as well as the market. These features result in the single most distinguishing characteristic of perfect competition: price taking behavior. From the viewpoint of a farm, what does price taking entail? A price taking farm believes that if it sets a price above the market price, it will be unable to sell any quantity of the good that it produces. On the other hand, should the set price be less than or equal to the market price, the farm can sell as many units of the goods as it wants to sell. From the viewpoint of a buyer, what does price taking entail? A buyer would obviously like to buy the good at the lowest possible price. However, a price taking buyer believes that if she asks for a price below the market price, no farm will be willing to sell to her. On the other hand, should the price asked be greater than or equal to the market price, the buyer can obtain as many units of the goods as she desires to buy. Price taking is often thought to be a reasonable assumption when the market has many farms and buyers have perfect information about the price prevailing in the market. Why? Let us start with a situation where each farm in the market charges the same on market price. Suppose now that a certain farm raises its price above the market price. Observe that since all farms produce the same good and all buyers are aware of the market price, the farm in question loses all its buyers. Furthermore, as these buyers switch their purchases to other farms, no adjustment problems arise. The demand is readily accommodated when there are so many other farms in the market. Recall now that an individual firm's inability to sell any amount of the good at a price exceeding the market price is precisely what the price taking assumption stipulates. Revenue. We have indicated that in a perfectly competitive market, a firm believes that it can sell as many units of the good as it wants by setting a price less than or equal to the market price. But if this is the case, surely there is no reason to set a price lower than the market price. In other words, should the firm desire to sell some amount of the good, the price that it sets is exactly equal to the market price. A firm earns revenue by selling the good that it produces in the market. Let the market price of a unit of good be P, let Q be the quantity of the good produced and therefore sold by the firm at price P. And then total revenue TR of the firm is defined as the market price of the good P multiplied by the firm's output Q. Hence, TR equals to P into Q. To make matters concrete, consider the following numerical example. Let the market for candles be perfectly competitive and let the market price of a box of candles be rupees 10. For a candle manufacturer, table 4.1 shows how total revenue is related to output. Notice that when no box is sold, TR is equal to 0. If one box of candles is sold, TR is equal to 1 into rupees 10 equals to rupees 10. If two boxes of candles are produced, TR is equals to 2 into rupees 10 equals to rupees 20 and so on. We can depict how the total revenue changes as the quantity sold changes through a total revenue curve. A total revenue curve plots the quantity sold or output on the x-axis and the revenue earned on the y-axis. Figure 4.1 shows the total revenue curve of a firm. These three observations are relevant here. First, when the output is 0, the total revenue of the firm is also 0. Therefore, the TR curve passes through point 0. Second, the total revenue increases as the output goes up. Moreover, the equation TR equals to P into Q is that of a straight line. Because P is constant, this means that the TR curve is an upward rising straight line. Third, consider the slope of this straight line. When the output is 1 unit, horizontal distance OQ in figure 4.1, the total revenue vertical height AQ1 in figure 4.1 is P into 1 equals to P. Therefore, the slope of the straight line is AQ1 by OQ1 equals to P. The average revenue of a firm is defined as total revenue per unit of output. Recall that if firm's output is Q and the market price is P, then TR equals P into Q. Hence, AR equals to TR by Q equals P into Q by Q equals to P. In other words, for a price-taking firm, average revenue equals the market price. Now consider figure 4.2. Here we plot the average revenue or market price y-axis for different values of a firm's output x-axis. Since the market price is fixed at P, we obtain a horizontal straight line that curves the y-axis at a height equal to P. This horizontal straight line is called the price line. It is also the firm's AR curve under perfect competition. The price line also depicts the demand curve facing a firm. Also that the demand curve is perfectly elastic. This means that a firm can sell as many units of goods as it wants to sell at price P. The marginal revenue MR of a firm is defined as the increase in the total revenue for a unit increase in the firm's output. Consider table 4.1 again. Total revenue from the sale of 2 boxes of candle is rupees 20. Total revenue from the sale of 3 boxes of candle is rupees 30. Marginal revenue MR equals to change in total revenue by change in quantity equals to 30 minus 20 by 3 minus 2 equals to 10. Is it a coincidence that this is the same as the price? Actually, it is not. Consider the situation when the firm's output changes from Q1 to Q2 given the market price P. MR equals to PQ2 minus PQ1 by Q2 minus Q1 equals to P. Q2 minus Q1 by Q2 minus Q1 equals to P. Thus, for the perfectly competitive firm, MR equals to AR equals to P. In other words, for a price-taking firm, marginal revenue equals the market price. Setting the algebra aside, the intuition for this result is quite simple. When a firm increases its output by 1 unit, this extra unit is sold at the market price. Hence, the firm's increase in total revenue from 1 unit output expansion, that is MR, is precisely the market price. Profit maximization. A firm produces and sells a certain amount of good. The firm's profit, denoted by pi, is defined to be the difference between its total revenue and its total cost of production. In other words, pi equals to TR minus TC. It is a convention in economics to denote profit with the Greek letter pi. Clearly, the gap between TR and TC is the firm's earnings net of cost. A firm wishes to maximize its profit. The firm would like to identify the quantity Q0 at which its profits are maximum. By definition, then at any quantity other than Q0, the firm's profits are less than at Q0. The critical question is, how do we identify Q0? For profits to be maximum, three conditions must hold at Q0. The price P must equal MC, marginal cost must be non-decreasing at Q0. For the firm to continue to produce in the short run, price must be greater than the average variable cost, P greater than ABC. In the long run, price must be greater than the average cost, P greater than AC. Condition 1. Profits are the difference between total revenue and total cost. Both total revenue and total cost increase as output increases. Notice that as long as the change in the total revenue is greater than the change in total cost, profits will continue to increase. Recall that change in total revenue per unit increase in output is the marginal revenue, and the change in total cost per unit increase in output is the marginal cost. Therefore, we can conclude that as long as marginal revenue is greater than marginal cost, profits are increasing. By the same logic, as long as marginal revenue is less than the marginal cost, profits will fall. It follows that for profits to be maximum, marginal revenue should equal marginal cost. In other words, profits are maximum at the level of output, which we have called Q0, for which MR equals to MC. For the perfectly competitive firm, we have established that the MR equals to P, so the firm's profit maximizing output becomes the level of output at which P equals to MC. Condition 2. Consider the second condition that must hold when the profit maximizing output level is positive. Why is it the case that the marginal cost curve cannot slope downwards at the profit maximizing output level? To answer this question, refer once again to figure 4.3. Note that at output level Q1 and Q4, the market price is equal to the marginal cost. However, at the output level Q1, the marginal cost curve is downward sloping. We claim that Q1 cannot be a profit maximizing output level. Why? Observe that for all output levels slightly to the left of Q1, the market price is lower than the marginal cost. But the argument outlined in section 4.3 immediately implies that the firm's profit at an output level slightly smaller than Q1 exists that corresponding to the output level Q1. This is the case. Q1 cannot be a profit maximizing output level. Condition 3. Consider the third condition that must hold when the profit maximizing output level is positive. Notice that the third condition has two parts. One part applies in short run while the other applies in the long run. Case 1. Price must be greater than or equals to ABC in the short run. We will show that the statement of case 1 save up is true by arguing that a profit maximizing firm in the short run will not produce an output level where in the market prices is lower than the ABC. Let us turn to figure 4.4. Observe that at the output level Q1, the market price P is lower than the ABC. We claim that Q1 cannot be a profit maximizing output level Y. Notice that the firm's total revenue at Q1 is as follows. TR equals to price into quantity equals to vertical height OP into width OQ1 equals to the area of the rectangle OPAQ1. Similarly, the firm's total variable cost at Q1 is as follows. TVC equals to average variable cost into quantity. The vertical equals to vertical height OE into width OQ1 equals to the area of rectangle OEBQ1. Now recall that the firm's profit at Q1 is TR minus TVC plus TFC, that is the area of rectangle OPAQ1 minus the area of rectangle OEBQ1 minus TFC. What happens if the firm produces zero output? Since output is 0, TR and TVC are 0 as well. Hence the firm's profit at 0 output is equals to minus TFC. But the area of rectangle OPAQ1 is strictly less than the area of rectangle OEBQ1. Hence the firm's profit at Q1 is area EBAP minus TFC, which is strictly less than what it obtains by not producing at all. So the firm will choose not to produce at all and exit from the market. Price must be greater than or equal to AC in the long run. We will show that the statement of case 2 is true by arguing that a profit maximizing firm in the long run will not produce at an output level wherein the market price is lower than the AC. Let us turn to figure 4.5. Observe that at the output level Q1, the market price P is lower than the long run AC. We claim that Q1 cannot be profit maximizing output level Y. Notice that the firm's total revenue TR at Q1 is the area of the rectangle OPAQ1, the product of price and quantity, while the firm's total cost TC is the area of the rectangle OEBQ1, the product of average cost and quantity. Since the area of rectangle OEBQ1 is larger than the area of rectangle OPAQ1, the firm incurs a loss at the output level Q1. But in the long run setup, a firm that such the production has a profit of 0. Again, the firm chooses to exit in this case. The profit maximization problem, graphical representation. Using the material in section 3.1, 3.2 and 3.3, let us graphically represent a firm's profit. Maximization problem in the short run. Consider figure 4.6. Notice that the market price is P, equating the market price with the short run marginal cost. We obtain the output level Q0. At Q0, observe that SMC slopes upwards and P exceeds ABC. Since the three conditions discussed in section 3.1, 3.3 are satisfied at Q0, we maintain that the profit maximizing output level of the firm is Q0. What happens at Q0? The total revenue of the firm at Q0 is the area of the rectangle OPAQ0, the product of price and quantity, while the total cost at Q0 is the area of rectangle OEBQ0, the product of short run average cost and quantity. So at Q0, the firm earns a profit equal to the area of the rectangle EPAB. Supply curve of a firm. The firm's supply is the quantity that it chooses to sell at a given price, given technology and given the prices of factors of production. A table describing the quantities sold by a firm at various prices, technology and prices of factors remaining unchanged is called a supply schedule. We may also represent the information as a graph called a supply curve. The supply curve of a firm shows the levels of output plotted on the x-axis that the farm chooses to produce corresponding to different values of the market price plotted on the y-axis, again keeping technology and prices of factors of production unchanged. We distinguish between the short-run supply curve and the long-run supply curve. Short-run supply curve of a farm. Let us turn to figure 4.7 and derive a farm's short-run supply curve. We shall split this derivation into two parts. We first determine the farm's profit maximizing output level when the market price is greater than or equal to the maximum APC. This is done. We determine the farm's profit maximizing output level when the market price is less than the minimum APC. Case 1. Price is greater than or equal to the minimum APC. Suppose the market price is P1 which exceeds the minimum APC. We start out by equating P1 with SMC on the rising part of the SMC curve. This leads to the output level Q1. Note also that the APC at Q1 does not exceed the market price P1. Thus, all three conditions highlighted in section 3 are satisfied at Q1. Hence, when the market price is P1, the farm's output level in the short run is equal to Q1. Case 2. Price is less than the minimum APC. Suppose the market price is P2, which is less than the minimum APC. We have argued C. Condition 3 in section 3 that if a profit maximizing farm produces a positive output in the short run, then the market price P2 must be greater than or equal to the APC at that output level. But notice from figure 4.7 that for all positive output levels, APC straightly exceeds P2. In other words, it cannot be the case that the farm supplies a positive output. So if the market price is P2, the farm produces zero output. Combine cases 1 and 2, we reach an important conclusion. A farm's short-run supply curve is the rising part of the SMC curve from and above the minimum APC, together with zero output for all prices strictly less than the minimum APC. In figure 4.8, the bold line represents the short-run supply curve of the farm. Long-run supply curve of a farm. Let us turn to figure 4.9 and derive the farm's long-run supply curve as in the short-run case. We split the derivation into two parts. We first determine the farm's profit maximizing output level when the market price is greater than or equal to the minimum long-run EC. This done, we determine the farm's profit maximizing output level when the market price is less than the minimum long-run EC. Case 1. Price greater than or equal to the minimum LRAC. Suppose the market price is P, which exceeds the minimum LRAC. Upon equating P1 with LRMC on the rising part of the LRMC curve, we obtain output level Q1. Note also that the LRAC at Q1 does not exceed the market price P1. Thus, all three conditions highlighted in section 3 are satisfied at Q1. Hence, when the market price is P1, the farm supply in the long run become an output equal to Q1. Case 2. Price less than the minimum LRAC. Suppose the market price is P2, which is less than the minimum LRAC. We have argued that if a profit maximizing farm produces a positive output in the long run, the market price P2 must be greater than or equal to the LRAC. at that output level. But notice from figure 4.9 that for all positive output levels, LRSC strictly exceeds P2. In other words, it cannot be the case that the farm supplies a positive output. So when the market price is P2, the farm produces zero output. Combining cases 1 and 2, we reach an important conclusion. A farm's long-run supply curve is the rising part of the LRMC curve form and above the minimum LRSC together with zero output for all prices less than the minimum LRSC. In figure 4.10, the bold line represents the long-run supply curve of the farm. The shutdown point. Previously, while deriving the supply curve, we have discussed that in the short run, the farm continues to produce as long as the price remains greater than or equal to the minimum of ABC. Therefore, along the supply curve, as we move down the large price output combination, at which the farm produces positive output, is the point of minimum ABC. Where the SMC curve cuts the ABC curve, below this, there will be no production. This point is called the short-run shutdown point of the farm. In the long run, however, the shutdown point is the minimum of LRAC curve. The normal profit and break-even point. The minimum level of profit that is needed to keep a farm in the existing business is defined as normal profit. A farm that does not make normal profits is not going to continue in business. Normal profits are therefore a part of the farm's total cost. It may be useful to think of them as an opportunity cost for entrepreneurship. Profit that a farm earns over and above the normal profit is called the supernormal profit. In the long run, a farm does not produce if it earns anything less than the normal profit. In the short run, however, it may produce even if the profit is less than this level. The point on the supply curve at which a farm earns only normal profit is called the break-even point of the farm. The point of minimum average cost at which the supply curve cuts the LRAC curve in short-run SAC curve is therefore the break-even point of a farm. Opportunity cost. In economics, one often encounters the concept of opportunity cost. Opportunity cost of some activity is the gain foregone from the second best activity. Suppose you have rupees 1000 which you decide to invest in your family business. What is the opportunity cost of your action? If you do not invest this money, you can either keep it in the house safe, which will give you zero return, or you can deposit it in either bank 1 or bank 2, in which case you get an interest at the rate of 10% or 5% respectively. So the maximum benefit that you may get from the other alternative activities is the interest from the bank 1. But this opportunity will no longer be there once you invest the money in your family business. The opportunity cost of investing the money in your family business is therefore the amount of foregone interest from the bank 1. Determinants of a farm supply curve. In the previous section, we have seen that a farm supply curve is a part of its marginal cost curve. Thus, any factor that affects a farm's marginal cost curve is, of course, a determinant of a supply curve. In this section, we discuss two such factors. Technological progress. Suppose a farm uses two factors of production, say capital and labor, to produce a certain good. Subsequent to an organizational innovation by the farm, the same levels of capital and labor now produce more units of output. Put differentially, to produce a given level of output, the organizational innovation allows the farm to use fewer units of inputs. It is expected that this will lower the farm's marginal cost at any level of output. That is, there is a rightward or downward shift of the MC curve, as the farm supplies curve is essentially a segment of the MC curve. Technological progress shifts the supply curve of the farm to the right at any given market price. The farm now supplies more units of output. Input prices. A change in input prices also affects a farm supply curve. If the price of an input, say the wage rate of labor, increases, the cost of production rises. The consequent increase in the farm's average cost at any level of output is usually accompanied by an increase in the farm's marginal cost at any level of output. That is, there is a leftward or upward shift of the NC curve. This means that the farm supply curve shifts to the left. At any given market price, the farm now supplies fewer units of output. Impact of a unit tax on supply. A unit tax is a tax that the government imposes per unit sale of output. For example, suppose that the unit tax imposed by the government is rupees 2. Then if the farm produces and sells 10 units of good, the total tax that the farm must pay to the government is 10 into rupees 2 equals to rupees 20. How does the long run supply curve of a farm change when a unit tax is imposed? Let us turn to figure 4.11 before the unit tax is imposed. LRNC naught and LRAC naught are respectively the long run marginal cost curve and the long run average cost curve of the farm. Now, suppose the government puts in place a unit tax of rupees T. Since the farm must pay an extra rupees T for each unit of the good produced, the farm's long run average cost and long run marginal cost at any level of output increases by rupees T. In figure 4.11, LRMC1 and LRAC1 are respectively the long run marginal cost curve and the long run average cost curve of the farm upon imposition of the unit tax. Recall that the long run supply curve of a farm is the rising part of the LRMC curve from and above the minimum LRAC together with zero output for all prices less than the minimum LRAC. Using this observation in figure 4.12, it is immediate that S0 and S1 are respectively the long run supply curve of the farm before and after the imposition of the unit tax. Notice that the unit tax shifts the farm's long run supply curve to the left at any given market price. The farm now supplies fewer units of output. Market supply curve. The market supply curve shows the output levels plotted on the axes that farms in the market produce in aggregate corresponding to different values of the market price, plotted on the y-axis. How is the market supply curve derived? Consider a market with n farms, farm 1, farm 2, farm 3 and so on. Suppose the market price is fixed at P. Then the output produced by the n farms is aggregate is supply of farm 1 at price P plus supply of farm 2 at price P plus supply of farm n at price P. In other words, the market supply at price P is the minimum of the summation of the supplies of individual farms at that price. Let us now construct the market supply curve geometrically with just two farms in the market, farm 1 and farm 2. The two farms have different cost structures. Farm 1 will not produce anything if the market price is less than P1, while farm 2 will not produce anything if the market price is less than P2 bar. Assume also that P2 bar is greater than P1 bar. In panel A of figure 4.13, we have the supply curve of farm 1 denoted by S1. In panel B, we have the supply curve of farm 2 denoted by S2. Panel C of figure 4.13 shows the market supply curve denoted by SM when the market price is strictly below P1 bar. Both farms choose not to produce any amount of the good, hence market supply will also be zero for all such prices. For a market Price greater than or equal to P1 bar but strictly less than P2 bar. Only farm 1 will produce the positive amount of the good. Therefore, in this range, the market supply curve coincides with the supply curve of farm 1. For the market price greater than or equals to P2 bar, both farms will have positive output levels. For example, consider a situation wherein the market price assumes the value P2, observe that P1 exceeds P2 bar, assumes the value P3. Given P3, farm 1 supplies Q3 units of unit output while farm 2 supplies Q4 units of output. So the market supplied price Q3 is Q0 Q5, where Q5 equals to Q3 plus Q4. Notice how the market supply curve SM in panel C is being constructed. We obtain SM by taking horizontal summation of the supply curves of the two farms in the market S1 and S2. It should be noted that the market supply curve has been derived for a fixed number of farms in the market. As the number of farms changes, the market supply curve shifts as well. Specifically, if the number of farms in the market increases or decreases, the market supply curve shifts to the right or left. We now supplement the graphical analysis given above with a related numerical example. Consider a market with two farms, farm 1 and farm 2. Let the supply curve of farm 1 be as follows. S1 of P equals to 0 when P less than 10 and P minus 10 when P less than equals to 10. Notice this, that S1 of P indicates that farm 1 produces an output of 0 if the market price P is strictly less than 10, and 2 farm 1 produces an output of P minus 10 if the market price P is greater than or equal to 10. Let the supply curve of farm 2 be as follows. S2 of P equals to 0 when P less than 15 and P minus 15 when P less than equals to 15. The interpretation of S2 of P is identical to that of S1 of P and is hence omitted. Now, the market supply curve SM of P simply sums up the supply curves of the two farms. In other words, SM of P equals to S1 of P plus S2 of P. But this means that SM of P is as follows. SM of P equals to 0 when P less than 10, P minus 10 when P greater than or equals to 10 and P less than 15, and P minus 10 plus P minus 15 equals to 2P minus 25 when P greater than or equals to 15. Price elasticity of supply. The price elasticity of supply of a good measures the responsiveness of quantity supplied to changes in the price of the good. More specifically, the price elasticity of supply denoted by ES is defined as follows. Price elasticity of supply ES equals to percentage change in quantity supplied by percentage change in price equals to del Q by Q into 100 by whole by del P by P into 100 equals to del Q by Q into P by del P, where del Q is the change in quantity of the good supplied to the market as market price changes by del P. To make matters concrete, consider the following numerical example. Suppose the market for cricket balls is perfectly competitive. When the price of a cricket ball is rupees 10, let us assume that 200 cricket balls are produced in aggregate by farms in the market. When the price of a cricket ball rises to rupees 30, let us assume that 1000 cricket balls are produced in aggregate by the farms in the market. The percentage change in quantity supplied and market price can be estimated using the information summarized in the table below. Price of cricket balls, quantity of cricket balls produced and sold. Old price P1 equals to 10, old quantity Q1 equals to 200. New price P2 equals to 30, new quantity Q2 equals to 1000. Percentage change in quantity supplied equals to del Q by Q1 into 100. equals to Q2 minus Q1 by Q1 into 100 equals to 1000 minus 200 by 200 into 100 equals to 400. Percentage change in market price equals to del P by P1 into 100 equals to P2 minus P1 by P1 into 100 equals to 30 minus 10 by 10 into 100 equals to 200. Therefore, price elasticity of supply ES equals to 400 by 200 equals to 2. When the supply curve is vertical, supply is completely insensitive to price and the elasticity of supply is 0. In other cases, when supply curve is positively sloped, with a rise in price, supply rises and hence the elasticity of supply is positive. Like the price elasticity of demand, the price elasticity of supply is also independent of units. The geometric method. Consider the figure 4.14. Panel A shows a straight line supply curve. S is a point on the supply curve. It curves the price axis at its positive range, and as we extend the straight line, it cuts the quantity axis at M, which is at its negative range. The price elasticity of the supply curve at the point S is given by the ratio MQ0 by OQ0. For any point S on such a supply curve, we see that MQ0 greater than OQ0. The elasticity at any point on such a supply curve therefore will be greater than 1. In panel C, we consider a straight line supply curve and S is a point on it. It curves the quantity axis at M, which is at its positive range. Again, the price elasticity of the supply curve at the point S is given by the ratio MQ0 by OQ0. Now, MQ0 less than OQ0 and hence ES less than 1. S can be any point on the supply curve, and therefore at all points on such a supply curve ES less than 1. Now we come to panel B. Here the supply curve goes through the origin. One can imagine that the point M has coincided with the origin here. That means MQ0 has become equal to OQ0. The price elasticity of this supply curve at the point S is given by the ratio OQ0 by OQ0, which is equal to 1. At any point on a straight line supply curve going through the origin, price elasticity will be 1. तो ये है इसका समरी और ये है इस चैप्टर का एक्सरसाइज। तो इसी के साथ हमारा आज का चैप्टर कंप्लीट होता है। और अगर आप चैनल पे नए हैं तो चैनल को सब्सक्राइब कर दीजिए और नोटिफिकेशन आइकन पर क्लिक कर दीजिए ताकि आपको सारे वीडियो के अपडेट्स मिल सकें। साथ ही अगर आपको वीडियो अच्छी लगे तो लाइक कर दीजिए और अपने दोस्तों के साथ शेयर कीजिए ताकि उन्हें भी हेल्प हो सके। तो हमारा ये सेशन यहीं तक था। थैंक यू, थैंक्स फॉर वॉचिंग।